Okay, we're going to be back with some more joystick fun. So last time we did joystick stuff, we made this little joystick tester thing, which I've been meaning to get round into soldering up for a more permanent device. But this one is for the 9-pin Atari type joysticks, of which I don't actually have one sitting next to me, which is a bit silly. So I'm just looking around if my voice is sounding different. And so, but that's what we had these 9 pins here. It's got a little D-shaped, I'm going to show you what it looks like without actually having an Atari joystick. So here's the Atari joystick end. So it looks like this, and it's a D-shape, looks like a serial output, serial connect cable, which is in fact what we're using here. So this is the end bit for it. If you haven't, I'd go back and watch the videos over this if you don't know anything about this, or look it up on the internet. And so here you can see how these basically work. They're just basically connections to switches inside the joystick. And so if you have a connection between pin 1 and the ground when the switch is activated, so when you press joy 0, which I'm not entirely sure, it's probably up I think, then that switch will connect, and then you'll get like current flowing through from pin 1 to ground, and that's how you detect whether or not you've pressed each direction. So you've got joy 1, joy 0, 1, 2, 3, so that's up, down, left, right kind of situation. There's two potentiometer connections, which are for these devices called paddles, which I did actually have some around, and we will look at those later on, but not today. And then there's the button, and then there's 5 volts supplied on pin 7. Now the thing is, I mentioned in the previous videos that so this is used by Commodore computers and by Atari computers back in the day, and a few other computers in similar forms like the Amstrad. But I also mentioned that they were used in other devices like the Sega Megadrive, and they're very similar in the Sega Megadrive, but they have a slight difference, and we're going to go through this. So I don't actually have a Sega Megadrive on me at the moment. I do, so a Sega Megadrive or Genesis, sorry, if you live in North America, then they're called Genesis, the Sega Genesis. But I do actually own a couple of Mega Drives. I don't own a Genesis, but I do own a couple of Mega Drives. I just don't know where they are. But I do have this thing here, which is a Mega Drive clone type thing. Not a clone, but it's like a more modern implementation of a Mega Drive by AtGames. I've heard people not really that fond of these things, but this one seems to work fine. This is like it's a thing from AliExpress with like 67 games in one. So it's a bit silly, but I do have a Mega Drive. I had a Mega Drive game sitting around, an actual Mega Drive game. So the trick is, not only do I not know where my Mega Drives are, I don't know where the joysticks are. The joy controllers, they're not called joysticks, they're joy pads. But I do have, because I went and bought one off AliExpress, a fake one. So these are like aftermarket type controllers. They're a little bit dodgy. Not the best build quality. This one here seems to have a funny fault. It doesn't go down very well. It doesn't click. It doesn't feel like a very good controller. In a future video, we're going to take this thing apart. But you might notice that this thing has more than is written down here. So this thing has 4 directions. So 1, 2, 3, 4. Diagonals are just doing 2 directions at once. And then you've got a start button, and then there's 6 buttons here. But we're going to pretend there aren't 6 buttons. We're going to pretend there's only 3. So there were 2 types of Mega Drive controllers. So the first ones had the 3 control buttons here, and then the later ones had 6 control buttons. That's my believing, not being a Mega Drive person. So it would be nicer if I started off with an actual 3 button thing. So we're only going to concentrate on the 3 buttons today. But the question becomes, well, they do kind of work in a similar way to this. How do they get the extra buttons? So if you look at it this way, forget those buttons, then you've got a start button, that's an extra button, and then you've got 2 extra fire buttons. So that's 3 extra buttons in here. So you could ignore the potentiometer stuff because you don't have pedals on a Mega Drive. So you could have 1 button there, and you could have 1 button there. And in fact, it's kind of strange. You don't need the 5 volts really, in general, unless you're doing like, you want to support some perhaps more complicated stuff. But let's just pretend for a second they could have got away with not having the 5 volts one as well. So they could have had 1, 2, 3, 4, 5, 6, 7, 8. 8 connections. So they could have used up everything on a 9-pin thing plus ground, and then they could have had that. But that's not what they did. So that's not how you actually get 8 connections out of less pins. So in fact, they're not using all of these things at all. So I couldn't find a nice picture to print out on the internet. But basically it looks like this. Here's my terrible handwriting, which is not going to be very readable on the screen. So pin 1 is up, so where it's got joy 0, joy 1, joy A1, joy A0 and all that. Basically that's up, down, left and right. So 1, 2, 3 is left and right. So on here, this is where the big difference comes in. You've got 5 volts going in on the potentiometer connection. So pin number 5 on a Commodore 64 is the potentiometer input. Which is just a resistor. It's a variable resistor. So in this, it just uses a variable resistor. So when you turn the controller, the resistance changes, and the computer reads that. So in this case here, you've got 5 volts going in on that pin. So that might not be a very good idea. So even though they probably do plug into Commodore 64s and Commodore Amigas and Ataris, they're probably not a very good idea, given that you've got now 5 volts going in on that point. They do have ground in the same place. But they have a different thing for the other remaining pins. What have we got here? So for the other potentiometer, it's got 2 different things here. But the important thing is pin number 7, which is 5 volts. This is probably going to explain why this didn't work. Which is 5 volts going in. Oh no. It should explain why it does work. Oh, we're going to have to damage this thing, aren't we? Ugh. Well, no, that's okay. That's okay. So we've got select here. We've got this select pin, which is number 7, or input, which is number 7. And then we've got button A, which is the button on the original layout. So they've kind of followed roughly how it works. If I plug this in to the thing, we're going to get to what that select. So the whole trick to give it away is the select pin. This does not tell you how you get 6 buttons out of this, but it will tell you how you get 3 buttons and a start out of it. So to get the 6 buttons, they do an even stranger thing, which kind of seems odd. So I'll plug in my 9-volt battery, I'll reactivate my keyboard, my joystick tester, and now when I press A, nothing happens. Right? When I press B, I get the button light coming on. And when I press that, so up gets 1 light going on, that gets 1 light going on. So those 2 work fine. That one works fine, and that kind of it does actually kind of work. So it's just really the down on this thing is super dodgy. Like it's very hard to actually get the down to press without pressing something else. Like you did see it briefly come on. That's down there. So it's upside down for you, but. Still, I can't do it anymore. That one little time. Just come on. So, the good thing is, so I don't know if we're going to actually get around to doing much in this video. But that's okay, we're going 10 minutes. We've got time. Alright, so I've got another one of these. So they come looking like this. This is brand new. You see, I just ripped the plastic off, so it wasn't quite the unboxing you were hoping for. I looked after this box. You can tell. It's very quality box. Though I have to be impressed. Like, I mean, you can knock the quality of this, but why do they still make these things? I mean, it's not really a Sega branded product. That's a fake Sega. For use on Megadrive, Deluxe Drive, and Wonder Mega. I don't know if you can actually see that it says that there. This is the fighting putt. So, as in golf, fighting putt. Pure Sega with 6 button controller. So, anyhow, does this one work any better than the last one? So we'll unplug this one. I kind of realize now maybe I could actually break these things. Okay, first thing we're going to do before we try plugging in another one, just in case I can break it, is I'm going to change this back to using a voltage regulator, which I probably should have planned for before I started doing this. Where did I put? Here we go. So right now we're using a really dodgy 5 volt input. if anybody can remember how I did this, I'm just going to take, I should be able to, I think, just take those out for a second, and we'll just run it off this board here, and we'll connect it up. Just get me some wires. Alright, what's an appropriate coloured? Black and white. So we'll just take 5 volts off here. So I want a nice 5 volts, and there's a reason for this, is that the IC that's, so in the originals, maybe this one doesn't actually matter so much, probably does. The originals, they had a particular IC which may not be particularly tolerant of things outside of 5 volts. It might be a TTL chip. I can't actually remember off the top of my head. So how did this thing work? How does the switch get into this? So that's power going over to there. Wait, turn this on. Well, the light comes on. That does nothing, which is good. So I think that my voltage regulator stuff is just taken out of the circuit. So that's fine. So now we're running off 5 volts. Now I'm going to try the new one. Just going to check. Should actually get out a voltmeter and check, but I'm not the multimeter and check. But we're not going to. The other one didn't blow up, so this one's not going to blow up. All right. So now we can. That one goes down, it goes up, goes left, goes right, fires, and it works. So we've kind of got it working, but we don't have the other buttons. So here we're going to get to the trick about how we can get a Megadrive, I can put that away, to read more buttons than you have inputs. And the answer is simply in pin number 7 here, which is 5 volts on a Commodore 64, is in fact the select pin, which says, well, if I'm high, then I get one set of buttons, and if I'm low, I get another set of buttons. And this is what this thing here is. So here we've got select is ground, in which case pin 1 is up, pin 2 is down, pin 3 and 4 will just go to ground. Pin 6 is A, button A on the joypad, which is that one there, and that's it. So everything. Oh, and pin 9 is going to be ground. But if select is high at 5 volts, then you get up, down, left, right. You still get 5 volts. Well, of course, there's not going to be a problem. This shouldn't. I don't see why this is going to be a problem for a. Well, it might be. Yeah, I'm just trying to work out if this really is going to be a problem to plug it into an Amiga or a computer that. So, if you plug it into a computer that's expecting that to be a potentiometer input, and you're not giving it 5 volts. So this is the important thing. 5 volts isn't coming out of the joystick controller. 5 volts is meant to go into the joystick controller at that point, and you're not going to be sending it in there. Does it still work? So I don't know. Well, we can find out. Well, first off, the important thing here is we're not actually putting 5 volts in there. So I haven't got pin 5 connected up at all. So it's still working fine with no actual supply voltage going into it. So it's probably getting the supply voltage through the select pin. When you play around with some ICs, is that you can sometimes get them to work even when they haven't got their supply voltage pins always hooked up the correct way, because they're getting it off the other inputs. So maybe that's what's happening here. So before we do anything, we're going to have to actually put 5 volts on pin 5. But this sort of shows you that it does actually work if you plug it into a Commodore 64, because you won't be putting 5 volts into there, but it seems okay to not put 5 volts into the supply of the joystick. So the joystick's not actually being powered. The joypad is not being powered if you put it into a Commodore 64. But I don't see, at the moment, I don't see how you're going to blow up your Commodore 64 or your Commodore Amiga by plugging in one of these things. More than likely you're just going to damage this. There's only one thing. So there's one way that this would happen, which is how you test the potentiometer, how you test that resistance. You do actually do this little strange trick with charging up a capacitor, and maybe that's how it breaks. It could break it. So, well, we have to investigate. I really do want to know for sure I mean, I could do more Googling on the internet, whether or not these are bad to plug into a Commodore 64 or Amiga or so on computer, old school computer, given that it seems to work without doing anything the same way as an original controller would work. But we still have to go to the select pin. So I think we are going to have to, and I'm going to explain it in a sec. So we're going to come back to this 5 volts not being supplied. But if you have select being ground, then pin 6 will give button A. We connected to button A, and pin, if it's high, then it will be connected to button B. So at the moment, it's connected to button B, and that's because the select pin is pin number 7. And the select pin here on the Commodore 64 is 5 volts. So I am putting into here, that little black wire is going straight to the very, very poorly colored wire there, is going straight to the 5 volts output. So we are in fact putting 5 volts into the controller and getting back and so it's basically the select pin is currently high. So what we're getting is up, down, left, right, and button B, which is why when we press button B, we get that. And we're not actually reading pin number 9, so we can't see what's happening with pin C. But if we were, then when we press C, we'd also get an LED on. So let us build the next thing. The first thing we're going to do is we're going to need a switch. So this is going to be, in this video we are just going to quickly make a manual tester for an old school thingy what's it, and then we're going to make a more intelligent one for the next videos in 2 different ways. So we're really going to stretch this whole thing out. And the first thing we want to do is we want to change, and I've just gone and remembered why this is not going to work. Oh, where did I put it? Sorry, I need my little tiny, what are they called? Screwdriver thingy, what's it? To, in fact, change the screws, change the bits and pieces on this. I'm not really good for words tonight, am I? Okay, so what do we want to do? We want pin 5 to have 5 volts on it. Well, that's easy, right? So where's my piece of wire? We're just going to use this piece of wire. I'm going to turn that off for a second, take the wires out, unplug this thing. We don't have to have everything on at the same time. It is kind of fun to do that, but no. Alright, and so I'm going to have to unscrew this. Surely I could actually choose a better color though. Surely I could put some degree of effort into getting the right colors here. So we'll do a nice light color for 5 volts. On this particularly dodgy looking wire. Okay, what happened to it? Okay, just go in the watch it. It's not going in, it's not connecting the way it's supposed to. Well, okay, fine. Alright, it's in you go. Oh, this is more complicated than I thought it was going to be. Okay, I just don't trust that wire. I feel like this type of wire has got worse over the years. Maybe I should stick with using these ones with the little rounded edges, or not. I always felt that these were cheaper. Oh, they are cheaper. They just get cheaper and cheaper. Everything is cheap. All right, so that is just going to go straight to the 5 volt rail. So now we are actually going to supply 5 volts like is requested. And I think this is important. So I think you can get away with putting 5 volts, with not connecting up this pin, not connecting up the supply voltage, if the select is high. So the chip inside. So there is some electronics in here which we're going to go into at some point. Not in this one. We'll go into what there's in the original Sega controller. That will... So it'd be good if I can find the original one to see if they still work. So, but they require 5 volts. What was I going to say? So I'm just thinking when you have 5 volts going into one of the input pins, that's enough to actually get the IC to work. Maybe. It'd be interesting to take it apart to see how it's wired up and how it actually works without the 5 volts on the supply line, but we've just plugged it in, so now we've got 5 volts. But the point is, if you don't have, if select goes to ground, then you're going to find that there is no way that any voltage. What smells? Something smells. It must be this thing. Something smells vaguely chemically. Probably those. It's a bit worrying. Okay, but anyway, the point is, yeah, if this is ground, then there's no way that you're going to get any power into the IC, so it probably won't work. We can always test this by unplugging this, but that was why we have to put the 5 volts in first. Then we might as well get, how much time we got? 8 minutes. We might as well get pin number 9 hooked up to something, which is the last one here. So we'll put this wire into here. We won't use the yellow ones. So if I keep the old yellow wires, which are much sturdier wires than the little cheapy things, I'm putting the jumper cable wires, jumper cables. It's not a car. We're not jump starting a car. Then I can take them out again when I go to build. Because how many Megadrive controllers am I actually going to test? But this is just going to lead into some interesting exercises. So I'm going to put this one over here, and we're going to quickly need some thingy. What are these ones? 1K. So we're going to need U, and we're going to put that one from. I've just got to remember how this actually works. No, that's how it works. So 5 volts is going to come out of this thing when we push the switch, I hope. So put in my current limiting resistor, and I just need a little LED. And what's this LED? I don't know what this one is. It's a bit different. So we'll try using that one. So we better just test that. So let's reactivate this device and see if it still works. And hopefully now we should get one more button showing up. So that works up and down. And that one's not showing up. It's not showing up. Wait, start. So when that is high, button C is supposed to make this one turn on. So I don't even know what that thing is. I think I've done it the wrong way. Oh, it's always going to ground. It goes out when I do that. That's the opposite. Okay, of course, it's got to go. Oh, that was a bad idea. How did I wire these things up? I've completely forgotten how this works. Okay, so this is a connection between, no, I think that's how it goes. So why doesn't that work the way it's supposed to? Oh, there we go. Now it works. Okay, so now we've got another fire button with this little tiny little LED. This is the only one sitting on my desk, and I've never seen it before in my life, so I don't know what it comes from. And so that works. So now when I press C and B, up, down, left, and right, but we still don't have A or start. So the last thing we have to do is right now we're supplying 5 volts to pin number 5, which is this orange thing here. So we're going to just quickly take that one out, put it over here, and we're going to put this little switch in. Actually, we're going to put it in the middle here. So this little switch is just going to go, and maybe we can do it straight. We can use these little resistors. We'll go through a 1K resistor. Current limits it for no reason at all, just in case. It's flickering around a bit now. Probably because we've now left that input floating, so it's not. Actually, why did the light come out? Go on and off. Who knows? So this way we can switch the input, the select, to either low or high with a little handy two-way switch thing. Alright, so at the moment it is going to low. Well, we'll start off with it going to high. So it should work just the way that we've been going through. So with it set to high, so with our select pin set to high, we get the normal behavior we've just been going through. But when we set it to low, does it actually react the same way as before? It made no difference at all. What? Alright, what have I done wrong? I've done something super wrong. Well, that says 3 volts on that one. 3.3 volts going through there. What if that makes a difference? Well, it should actually be going to... Alright, hold on, that is pin 5, right? So the orange one is pin 5. Ah, that's the 5 volt one. What are you doing? Man, how does this thing even continue to work? No, what is the select pin? The select pin is number 7, which is the black wire. I knew it was one of these ones that was... that's going all crazy, because it's now floating. So we might turn it off while we fix it up. And well, I've got to get it all the way. Okay, I'm going to put it there for a second, and we need a long wire. Where are all my really, really long ones? There we go. Oh no, that's not a long one. I do have long ones. Hold on. Here we go. Here we go. I went and bought a whole pile of long ones. We're almost there. We've got 2 minutes left. We can do this. So this wire is the actual select pin, not the power supply pin. And that one can go into there. So now... Oh, well, that's just not what we want. Well, this just gets more interesting, doesn't it? Okay, so now we've got high, and that's what we wanted before. And now we're going to pull it low. And... Well, it does actually work, but we've got these two on. Oh, they're pulled to ground, of course. They're going to be pulled to ground, and that's what's making the lights come on. Aha! So I've got to think about that for my next thing. I keep beginning, because you know the whole point is that... So, that's right. So when the select is ground, then pin 3 and 4 get pulled to ground, which is why the LED comes on, because they're connected from the 5 volts. And when the switch is on, they get pulled down to ground. So that's what's making those things come on. So up and down still work, but those are pulled to ground. And then we have button A is connected to 6. So now this is button A doing it. But when we switch back to high, it's button B doing it, is making that LED come on. And then when we go back to here, we can detect the start button. So it all works the way it's supposed to work. So I think that's kind of cool. So the next thing is we're going to make a better one of these that doesn't use a silly switch, but actually has LEDs for every single button here. And we're going to go through about the last 6 buttons, but that gets a bit more complicated. That can come back to at the very end, but I'm going to do that on the Arduino. So the next time we're going to make an Arduino project to detect all the buttons, and then we're going to make a old school IC solution to detect all the buttons. So thanks for watching, like, share and subscribe.